Today we're going to be talking about inequalities and absolute value inequalities. Before we get into inequalities, I want to first go over what we call interval notation. So interval notation is a way of notating a set of numbers by saying we are looking at the set of numbers between this number and this number. So here we're going to use C and D to represent those numbers. So say C and D are real numbers where C is less than D, C is the smaller number. Then, if you use this notation with square brackets and a comma separating the two values, that denotes the set of all real numbers, x, such that C is less than or equal to x, which is less than or equal to D. If you use parentheses instead of square brackets, that denotes the set of all real numbers x, where x is between C and D, but not equal to C or D. Now you can combine these two depending on the set of numbers you're working with, and if you have a square bracket on the C but a parentheses on the D, that means it could equal C but not D. Same thing the other way. So if you have the square bracket on D and the parentheses on C, then x could be equal to D but not equal to C. Now for a lot of what we're going to be doing, we are going to be practicing using this interval notation. We use this interval notation when we're talking about graphs in general, when we're analyzing them, so it's a good way to practice as we're talking about how to solve inequalities. So let's practice using interval notation. So denote the set of all real numbers x using interval notation when you have -2 is less than or equal to x less than or equal to 7. So here, x is between -2 and 7, and it could equal -2 and it can equal 7, so we are going to use square brackets. So our answer here is square bracket, -2, comma 7, square bracket. Next one, denote the set of all real numbers x using interval notation. We have 7 less than x less than 135. In this case, x is not equal to 7 or 135, but it's everything in between. So in this case, we'll use parentheses. So this will be parentheses 7, comma 135, parentheses. Last one, denote the set of all real numbers x using interval notation. So x is greater than or equal to 12. Now in this case, you see how we don't have two real numbers that are given to us. But x can be anything starting at 12, and it also can be anything greater than 12. How far up does it go? Well, there's no limitation on how high x can go, so we can say it goes from 12 all the way to infinity. So it equals 12, so we know we have a square bracket on the 12. We'll do a comma, and then we'll do infinity. Now typically with infinity, because it's not an actual number, we are going to use parentheses on it. All right, now let's talk about solving linear and compound linear inequalities. So a couple review of the basics. So first, you can add or subtract the same quantity on both sides of the inequality. You can also multiply or divide both sides of the inequality by the same positive quantity. But when you multiply or divide by a negative quantity, you have to reverse the direction of the inequality. So for example, if you were asked to solve this, 2 less than -3x plus 5, you can subtract 5 from both sides as you would any other equation. And now you're going to divide -3. But because you're dividing by a negative number, you have to reverse the direction of the inequality. So this is going to become 1 greater than x. Now let's look at an example where we have a compound linear inequality. So a compound linear inequality means that you have more than one inequality in your expression. So here we have 2 less than or equal to 3x plus 5 less than 2x plus 11. What we're going to do is we are going to split this up into two separate inequalities and solve them before putting it back together. So I'm going to split it up into 2 is less than or equal to 3x plus 5, and 3x plus 5 is less than 2x plus 11. I'm going to solve each inequality, and I know that both of them are going to have to be true, and so we'll write an inequality that combines both of our solutions. So in this first one, we have 2 less than or equal to 3x plus 5. So I'm going to subtract 5 from both sides. I end up with -3 less than or equal to 3x. I divide both sides by +3, so no need to change the inequality here. So that becomes -1 less than or equal to x. Let's solve the second inequality. So in this one, I'm going to subtract 5 from both sides, subtract 2x from both sides, and that leaves me with x is less than 6. Now I'm going to combine both of those into one compound inequality. So -1 is less than or equal to x, which is less than 6. Now let's write that in interval notation. So we have a square bracket on the -1, a parentheses on the 6. So we have -1, comma 6. Now on a number line, the way we would graph this is we would put a open circle when it's not equal to that point, but a solid circle when it is equal to that point. So in this case, it is equal to -1, but it is not equal to 6. And then we shade everything in between, because it is the set of real numbers between -1 and 6, including -1, but not including 6. Let's look at one more. We have 4 is less than 3 minus 5x, which is less than 18. Now, notice the difference between this example and the example before. In the example before, we had x showing up in multiple places, so we had to break it down into two separate inequalities. However, when the variable appears only in the middle of the compound inequality, then you can actually streamline or shortcut the process by doing everything to each section of the inequality. So in this case, for example, if I subtract 3 from all 3 sections, then I don't need to write two separate inequalities. So subtract 3, so that I have 1 is less than -5x, which is less than 15. And then now I'm going to divide everything by -5. Now dividing by -5, I still have to change the direction of the inequality. So this becomes -1/5 is greater than x is greater than -3. Now typically we like to write everything going from smallest to largest from left to right. So I'm just going to rewrite this so that the -3, which is the smallest, is going to be on the left. So we have -3 less than x, which is less than -1/5. Writing that in interval notation, because x is not equal to -3 or -1/5, we're going to use parentheses on this. So -3, comma -1/5 in parentheses. All right, and then on the number line, this means that because it's not equal to -3 or -1/5, we are going to draw open circles on -3 and -1/5, and then shade everything in between. And that's our answer as graphed on the number line.